Welcome to Chapter 4 for trigonometry. So in Chapter 4, we're going to take our unit circle, which we've mastered in both degree and radians, and we're actually going to apply this idea to the sine and cosine and tangent curves in the coordinate plane. So what would it look like if we found the sine of 0 or things like that? So these graphs are predictable, okay? Some things that we can think about that are predictable in life are your heartbeat, right? Your heartbeat is on a cyclical rotation, hopefully if you have a normal heartbeat. The tides as they rise and fall, you can predict when the tide is going to come in versus go out, same as sunrise, right? In the winter, it's going to be a different time versus the summer, but it all is based on those cycles. So if we were to graph these things over time, it would be kind of a nice sort of curve. Obviously mine isn't perfect, but you kind of get the idea as especially the tide levels as they come in and they get higher on the sand versus when they go out. It's all periodic and cyclical, okay? So same kind of idea for sine and for cosine. We have a periodic function, meaning that it's just it's going to repeat itself over and over again because it's on this repeating cycle. Okay, so we have sine and cosine is what we're going to start talking about first. If I could get my highlighter, sine and cosine. Okay, remember the reciprocals of sine and cosine are secant and cosecant. And all of these are periodic, and they actually have a period of 2 pi. We've seen this before because think about when you make a full rotation of the unit circle, you go from 0 to 2 pi. Every time you travel and you circle around 2 pi, you make a full rotation of our 360 degrees. Okay, so this is a look at our sine function. So you're probably wondering, where in the world did they get these values? We got them from the unit circle. But instead of looking at them as right triangles as we rotate around the origin, we're actually going to look at these as points, as x and y coordinates. So to start out, if our x coordinate was 0, right, we're going to plug in our x. Something's going to happen just like at a factory or a machine, and then out comes the y. So if we find the sign of 0 on our unit circle, that is 0. And that's why our first point is at 0, 0 right here. Okay, our next value is going to be pi over 2. Okay, the sign of pi over 2 is a positive 1. So our next x-axis, our x value is pi over 2, while our y coordinate is at 1. Now we're going to keep moving. Imagine we're rotating around the unit circle. Sine of pi, we're back to 0 because remember we're back on the x-axis. So our next point would be pi 0. Then we're going to move into sine of 3 pi over 2. So now we are down on the negative y-axis. So this would be negative 1. So we're at the point 3 pi over 2, negative 1, down here. And last but not least, sine of 2 pi, and that brings us back to 0. So our last point is at 2 pi, 0. So if we make our scale on the x-axis go from 0 to 2 pi, so we're going basically in increments of pi over 2, this creates our nice sine curve here. And that is the end of one cycle, okay? That's why we're saying the period here is 2 pi. This is one full cycle of sine. If we were to keep going, right, like we could type in 5 pi over 2, 6 pi over 2, 7 pi over 2, and keep going, this graph would just keep repeating itself. It would just keep rotating up and down and up and down. Excuse me. Okay, so just some more details about the sine function. Okay, our domain, which remember is our x values, is from negative infinity to positive infinity. It's going to go on forever and ever. Our range, remember our y values, the max is +1 and the min is -1. So it's just going to keep bouncing back and forth between -1 and 1 back and forth. What else we have? We have the sine function is an odd function. Okay, it's symmetric about the origin. We have a period of 2 pi, meaning one full cycle is created by once we travel to 2 pi. Our x-intercepts are at 0, pi, 2 pi, so on and so forth. They're all integers and multiples of pi because, remember, goodness, if I could talk, sine is 0 when we are on the x-axis. So those are all values that would be on our x-axis in our unit circle. Okay, so let's keep going. Let me find it. Okay, so that would be our nice sine function. Okay, moving into cosine, this is going to look a little different because of the fact that it's a different function. Okay, but the idea of these points are all the same. Okay, sine of 0 is 1. So that's why our first point is starting up here on the y-axis. Sine of pi over 2, or I'm sorry, cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. Okay. So notice these graphs are similar, but they're different. Okay. The cosine is still going to go in a cycle, but notice the starting value changes because we're calculating a totally different function. We're calculating all the x coordinates on your unit circle versus all your y coordinates when we talked about sine. Okay, so notice when your cosine starts, because sometimes you're gonna have to figure out, are we talking about sine or cosine from a graph? The cosine function starts at its max. It's either going to start at its max or min, meaning it's going to start at 1 or -1 if we don't have any transformations. So notice sine starts in the middle. It's always going to start at the origin, unless, like I said, we have some sort of shift. Okay, so here is cosine. A lot of these things you'll notice are similar or the same to sine, but it's going to change a little bit because it's a different function. Domain is the same. We're going to go from -infinity to +infinity. Our range still bounces back and forth between -1 and 1. Cosine is an even function. It's symmetric about the y-axis. It again, forgot to erase this. It again has a period of 2 pi, so that means we'll complete one full cycle as long as we go from 0 to 2 pi, or an increment of 2 pi. And then a little different, the x-intercepts are in increments of pi over 2. Okay, and the reason that is because the cosine of pi over 2 in those multiples is 0. Okay, so just to talk a little bit more about the graphs. So we have kind of the general idea of what these graphs are going to look like. Okay, notice on this graph we have sine in blue and cosine, or I'm sorry, sine in red and cosine in blue. So they're very, very similar. It's almost as if it's just like translated slightly to the left or to the right, whichever way you're thinking about it. So the max and the min are the same, but we're just kind of shifted over there. Okay, so the first two things we're going to talk about in calculations for our graph, let's do some pink, is our amplitude. Okay, this amplitude is going to decide, are we going to compress the graph or are we going to stretch the graph? Okay, how tall are these curves going? Are they going super high or are they going super skinny where it's like a low subtle wave? That's all created by our amplitude. So the amplitude is outside of our function. So this would be like if we had a constant that was multiplying the sine or the cosine. Okay, for example, this would be like if we had y equals -2 sine, oh, that's not an n, of x, or y equals 10 times the cosine of x, okay? We're going to have a value that's outside of the function that's multiplying it, which this will obviously change the y values if we're having something extra multiplied. So to find the amplitude, you are going to find something called the midline, okay? So our midline in these graphs, let me pick a different color besides these, okay? So if we don't have any sort of vertical, horizontal shift, we're not manipulating the graph at all, our midline is basically where the symmetry is happening. If we were to draw a middle line like right through the middle of the graph, it would just be right here on the x-axis. Okay, this would be our midline. This midline stays here unless we're manipulating the equation in some sort of way. So for this, our midline stays at y equals 0. Okay, the reason we call it y equals 0 is because it's a horizontal line. So if we change, if we create a transformation, then this will change. But from here, we would just count how far away are we from this midline. So if we don't change the amplitude, then if the amplitude is just 1, right, we're going up 1 from the midline and down 1 from the midline, then we don't have to change anything. But as soon as we start changing things, that's when our midline might change and our amplitude might change. So if we had an amplitude in this one of -2, that means it would stretch our graph to where our distance from the midline would be +2. Same thing for y equals 10 cosine of x. That distance between your midline in the middle and the top or the bottom of your graph is 10. Okay. We also have something that would change the period, right? If we elongate and make it a more shallow curve, we're going to make our period longer. It's going to take longer for our function to get through one full cycle. Or we can make it really, really, really fast. And that way our period would be a lot shorter. Okay, so this could be like, maybe it's just super shallow. Or maybe it's like this. Oh, wow, that's horrible. Where it would be like, goodness, if I could draw it. It would be like really tight. Okay, you're going to have a shorter period the faster you can get through one full cycle. Okay, so if we looked at the function like y equals 5 times the sine of 4x, our amplitude is going to be the 5. Okay, that's changing how tall the graph is. But our period is also changing because we're multiplying we're multiplying on the inside of our function, okay? So we can always find our period by taking 2 pi over b. Okay, so for this, our period is 2 pi over b. b is just the coefficient on the x. Okay, so we can see that here with sine and cosine. So we're going to take that coefficient and we're going to divide 2 pi. So our coefficient is, no, not 5, it's 4. And we can simplify 2/4 to 1/2, so this would become pi over 2. So that means that instead of waiting all the way from 0 to 2 pi, we would be able to get through an entire cycle in just from 0 to pi over 2. Okay, and then this last little bit is just so that you can have both functions together. Okay, so that's the picture of both, and then some more information just kind of wrapping everything up.